Hello math students, good to be with you today virtually. Today we're doing a flipped classroom, and I put 3 basic points here on what's motivating us to do this. As far as the purpose and motivation for the flipped classroom, it puts the responsibility of learning where it should be on you, the student, so that's one of the reasons that we're going to be doing this. There is a professional benefit also. As many of you know, before coming to AAMU, I worked for almost 20 years full-time in the corporate world as an applied mathematician. You know, applying things like calculus and linear algebra and numerical analysis and differential equations to real-world problems of interest to various customers. So in those settings, your supervisors expect you to be able to do what's called self-learning, because there'll be many things that you'll have to do on the job that you may have covered in school that you may have forgotten. So you're going to need your textbook, in many cases, on the job. And you're going to have to be able to know how to go to the textbook and get the information that you need to do in order to perform your job. So there is a professional benefit for the flipped classroom because it'll get you used to being able to find information for yourself, and that will help you after you graduate. And finally, realizing that flipped classroom may not be suitable for all topics, I have identified some topics that I believe it is suitable for. So we'll be covering 2 of those topics in these flipped classroom sessions. And the first topic we're going to be doing is from your textbook. It's under section 4.2, and it's called area. The topic is called area, and we've been covering some of this in class already. So today I'm going to kind of dive more into some of the details. So this is section 4.2, area. Okay, so if you recall, we did a lecture, I believe it was last week, on sigma notation. So, assuming that you understand all that material, today we're going to expand that and discuss in more detail how that relates to area. So, looking at the summation formulas in your textbook, and these are all on page 265 if you need a book reference. The first formula is summation I equals 1 to n of c equals c times n. The next formula is summation from I equals 1 to n of I, and that equals n plus 1 times n plus 1 over 2. The third formula is summation I equals 1 to n I squared. That equals n plus 1 to n plus 1 all over 6. And the last formula we're going to be dealing with is summation I equals 1 to n I to the third power equals n squared n plus 1 squared over 4. So in the lecture we did previously on sigma notation, we spoke about how to understand the formula, and we said that if we make n equal to 5, for example, then the summation from I equals 1 to 5 of I equals 1, I simply equals 1. At I equals 2, I simply equals 2. At I equals 3, I simply equals 3. At I equals 4, I simply equals 4. And at I equals 5, I simply equals 5. And what the summation means is we stop at 5, and then we add up all the numbers that we obtain. So if you add 1 plus 2 plus 3 plus 4 plus 5, you'll get 6 plus 9 for a final answer of 15. If I did my math correctly, that's 3 and 3, that's 6, plus 9, 15, yes. Okay? Now, what this formula is saying is there's a shortcut for doing this summation. And if you know that n equals 5, you can essentially apply the 4-step process we've been discussing all semester. You know, state the formula, substitute, label, and solve. And essentially plug in your n equals 5 into the formula. So that's going to be a 5 there. Well, if n is 5, then using addition, n plus 1 must be 6. Let's divide that by 2. We have 5 times 6 is 30. 30 divided by 2 is 15. Okay, so you may not be impressed by that. You may say, why use this formula? Well, what if I had asked you to add 10,000 numbers? Well, if you add 10,000 numbers, using this approach is going to take you a very long time. But if you use this formula, you'll get it done much faster. So let's not use 10,000, let's use the number 200, okay? So I think you would agree that you would not want to do this process 200 times and add 200 numbers. I think you would agree with that. So let's use this formula to do that. So let's find some space on the board here. So let's say I equals 1 to 200. All right. So this essentially means add up 200 numbers, but we're going to go straight to the formula. N is equal to 200. N plus 1 equals 201. We're going to divide that by 2. And if you have a calculator, this is fairly easy to do. You just basically multiply 200 times 201, divide that by 2. So that's basically a few keystrokes in calculator versus 200 keystrokes in calculator by adding 200 numbers. So that's the advantage of using the formula. So let's move on to a more detailed example. And what I'm going to do is I'm going to move some of these formulas to the side of the board here because we are going to be referring to them for the next example. So I'm going to move the first one over here. I equals 1 to n. C equals C n. And then I'm going to move another one down here. I equals 1 to n. I equals n times n plus 1 all over 2. And then I'm going to move the third one over here. That's going to be I squared equals n times n plus 1, 2n plus 1 over 6. So all I did was I just move these formulas over. We're not going to use the fourth formula for this next example, so we won't worry about that. We won't worry about the fourth formula. Okay, so this is example 2 in your textbook. It's on page 265. So let's make some more room here. So this is example 2. And this is on page 265 in your text. So we have the following problem. I equals 1 to n, I plus 1 over n squared. And we have n equals 10 and n equals 1,000. Okay? So that's the problem that we're working on. All right, so the first thing you do is you can recognize that n squared is a constant. So let's do the example for n equals 10. So n is not going to change. We're going to fix n at 10. So if we do that, we have summation I equals 1 to n I plus 1. Now, if you notice, I'm going to put the 1 over n squared here. Okay? So I want you to recognize something here. Because n is a constant, n squared is a constant also, we can factor it out. And as you can see, if you multiply 1 times I plus 1, you still get I plus 1. You multiply n squared times 1, you have the original expression. So hopefully that is clear to you. And then the next thing we're going to do is we're going to use somewhat of a distributive property for the summation, or the sigma symbol here. So we're going to have 1 over n squared on the outside. We're going to have summation I equals 1 to n of I plus the summation of 1 I equals 1 to n. So essentially what I did was I broke this up into two different summations. You know, there's your I, and then here's your 1 from there, from the original expression. The next thing we're going to do is we're going to refer to the formulas we have on the side here, and we're going to internally, mentally apply the 4-step process we've been discussing all semester. You know, state the formula, substitute, solve. And so you're very familiar with that already. And we're going to determine, essentially through pattern recognition, what does this formula match on the board there? Well, this actually matches this, okay? So that being said, we can label the n to be 5. And essentially all we have to do is substitute into the right-hand side of the formula. So we're going to get an answer of 5 times 6 over 2. So that evaluates the first summation. Let's do the second summation. Now let's look to see what this matches. Well, if you look out of the three formulas, this matches the first formula, where C stands for a constant. So if we label the C to be a 1 for this specific example, and n is still 5, that didn't change. If we substitute into the right-hand side of that formula, we get 1, which is C, times n, which is 5. And let's go ahead and finish solving this. So that's going to be 1 over 5 squared times 30 over 2 plus 5, which is going to be 1 over 25 plus, times 15 plus 5, which will be 20 over 25. And you can reduce that by recognizing that the factors of 20 are 4 and 5, so that will be 4 times 5 over 5 times 5, which is 4 over 5. Okay? So that's generally how you do this. And we're going to take a pause and let you think about what we just talked about.